Hello everyone, welcome to my channel. So today we are going to do blind 75's one of the question binary level tree, basically binary tree level order traversal. So now if you see, so this is the sheet which we are solving. So in this sheet we have already solved a lot of questions, means about 50 questions we have already solved. And now in this, now today the question which we are doing is this one, binary tree level order traversal. Basically we are doing this question. So I've already opened the Leetcode link for the same. So this we will check and solve it, and after that we'll go ahead with the other three questions which are there in upcoming videos. So that is what we are going to do. So now let us first read this question, then we'll check for the constraint, and then we'll check that what are the possibility of solving this particular question, means basically what is the intuition behind solving this particular question, and how that particular solution which will be there, what would be time complexity and space complexity, all these things which are required to be discussed. Even in interviews also all these stuffs are being judged, that what was your intuition behind the question, and what was the time complexity and space complexity, and why you thought like that, and everything. So all those things we will be covering here, so that you are completely interview ready for the upcoming placement preparation, whatever you are doing for whichever company. But if you got this question, then short you will be able to solve it. Like that we are required to just get ready with it. So now here the question which reads out is, given the root of the binary tree, return the level order traversal of its nodes value, that is from left to right, level by level. So basically here we are given with a binary tree and we need to go basically level by level. We need to go level by level, right? That means whatever we are required to do here is, so here this tree which is given to us, so first we will be checking this level, then we will be going ahead with this level, and then we will be going ahead with this level. Basically each level whatever nodes which are there that are required to be returned. So here at the first level we can see that we have 3, only one node is there, so that's why we are returning just 3 as the answer for the first level. Then for the second level we have 9 and 20. So from left then right, so 9 and 20 is being returned here, and then 15 and 7 which is there, so first 15 and then 7 is being returned here. So like that only for whatever tree which would be given to us, so at a particular level the number of nodes which would be there, all nodes we are required to return. So basically if you see like if some tree is something like this, 1 2 3 and then 4 5 then 6 then 7, and say here it is 8 and here it is 9. So here how the nodes would be returned here. So basically here the nodes would be returned like 1, and then the next one which would be there, so 2 comma 3, and the next one 4 5 6 7, and then we have 8 and 9 at same level. So this is how the answer of this particular would be. So this is like where at each level we have more than one nodes. If there is something like this, means a skew tree which is there, so here the answer would be something like this, means 1 then 2 then 3 then 4. At each level one node which is there, so that all we will be returning. So these are the like maximum possibility of trees which I can think of at this particular moment of time. But for how to solve this particular question, and even before solving that, let us check the constraints also. So the constraints which are here, so here the constraint is that the number of nodes in the tree is in the range of 0 to 2000, and nodes value, anyhow we are not concerned with the node value, whatever node value would be, because we don't need to add or multiply something like that, so that's why we are not concerned with that. So the number of nodes in the tree is in the range from 0 to 2000. So in that context, even if it is a skew tree also, the one which I have drawn just now, even if it is just like this and we go ahead and solve it in order of n complexity, it will work fine for us. So that is the thing. Now comes the part that how we are required to solve this. So in traversal of binary trees, because this is a binary tree, there are two methods by which we can traverse. One is the BFS and the second one is DFS. So now here, because now what is BFS, what is DFS, I hope you are clear with that. So BFS is basically when we need to go ahead level by level, and DFS is something where we need to go ahead into depth of a particular subtree, and then we will be going into depth of the another subtree. So here, so if we want to do BFS, so it would be something like this. Although answer which we will be getting, because anyhow we are traversing. So in BFS, the thing would be, first it will check for this, then it will check for this, and in this direction only, left and then towards the right, like this it will check. But if it would have in DFS, then in DFS case it would be, first it will go into depth of this, then it will return to 2, and then it will go to 5, then it will go to 2, and then 2 will return to 1, then this 1 will go to 3, then 3 will go to 6, then 6 will return to 3, and then 3 will go to 7, and then 7 will return to 3, and then it will go to 1. Like this DFS would be, and it will take like seriously a lot of time, because it need to go into the depth. But here the question is that we don't need to go into depth like the way it is being in DFS. We need to go to the depth, but that also by first completing the previous level completely. Means whatever nodes which are there at first level, that need to be printed. Then whatever nodes which are there at the second level, all those nodes need to be printed. But you can see in the case of DFS how the things are, that here in the first level whatever node is there, fine. But in the second level, it has first gone to the second level one node, and then immediately it got to the third level, right? We don't require anything like that. What we require is something like this. Even our answer also says that we require that first level all nodes should be there, second level all nodes should be there, and third level all nodes should be there. So this is the crux of this question. And now in that context we chose BFS over DFS, because we can clearly see here the time complexity in the BFS, although both will give us order of n, but the answer which we require would be given us in basically in less time complexity, and less time would be because of the BFS. So let us now code this particular question. We will be going ahead and doing BFS. So now, 1 minute. Let us go ahead and code this particular question. Now for BFS part, what all we are required, and as per the question, we are required to return vector of vector int. So for that purpose, we will take vector of vector int answer. This we will be returning at the end. That's why we have chosen. For BFS we require a queue, so that we will be taking, and the queue, in that we will be storing 3 node type. So that's why we are taking 3 node star as the data type of this particular queue. Now the first check which we need to keep is that if a root is null, sorry, then in that context we need to return null. Basically here it is vector of vector int, so in that context we won't be returning null as it is. We would be required to return one empty vector, right? So that would be our base case. So if root is not there, that is not root, then we will be returning the empty vector. This is our base case. Now comes the next part, that before starting with the BFS, we required that there should be root node inside our queue. Then only we can put the condition that while queue dot empty is false, then only we will be proceeding ahead, right? So that's why we are required to push our root into the same first thing. Now next we'll go ahead and write our while loop, and in that our logic of BFS would be there. So while queue is not empty, then first thing which would be done is that we'll take the size of that queue size equals to queue dot size, and then uh, next thing which we are required is we are taking one vector in which we will be storing at a particular level whatever nodes which would be there, that all we will be pushing into the same. And then after pushing all those into the same, we will be pushing this particular vector to our main answer vector, and then we'll empty out this particular vector. Anyhow, at this point it will be reinitialized again and again, so by default whatever was beforehand, that would be already emptied. So this is the thing. Now we'll get one loop, and then we need to go till q size I plus plus. So now in this particular, we will check whatever is at the top, means at the front of a queue, so that we will be taking q dot top, and then we will be popping out from the queue whatever is there in the queue. So by this we will be having whatever was there at the top of that particular queue. In queue there is not top, there is front. Basically whatever would be there in the front of that particular queue, that we will be having. And now we have popped that as well. Now what we are required to do is whatever we will be encountering the next, means whatever left of that particular, means here whatever the left side and whatever the right side would be there of this particular node for the next level, because anyhow left and right would be at the next level only, right? So whatever would be left and right of this particular levels node, that we are required to push into the queue. And like that only, if we would be having some more nodes, so because we are having this particular queue size, so because of that whatever nodes which are there in the queue, that all will be we will be getting them, and whatever left and right nodes which would be there, that we will be pushing into our queue. And like that we will be able to push all the nodes which are there at that particular level. So that is what we are going to do here. So now if current left exists, because there is possibility that left doesn't exist, it is null, right? So that's why before accessing that, we need to keep a check that it really exists, then only we will be pushing that particular into the queue. And then same goes with the left side. If the right is there, then only we will be pushing to the right by doing current and then right, and then like this only, because we will be able to push whatever were there, all that we have already pushed. But now comes the part that we have our current value which need to be there in that temporary vector for present level, right? So that's why at this point only we will be pushing current value. We push this current value, and fine, it got pushed. Then the thing would be, if there would be any other node in the queue, that we will be getting into current again, and its left and right would be pushed, and again that particular node itself would be pushed into the table. Like that it will go on until this queue size gets exhausted. Now after that, after it comes out, then we need to push that particular temp which is there, answer dot pushback temp. And then anyhow while loop it will be running, because we have freshly pushed some of the values into our queue, right? So because of that this will hold true, and because of that only our queue size would be updated, and even at this point our temp would be initialized. So whatever was there in temp beforehand, that will get erased. And then after that same process will be carried again, and then at the end we will be required to return our answer. So that is what we would be required to do. Now here comes the part, the time complexity and the space complexity. So here if you see the time complexity which is there, it is traversing at max or n nodes which are there. Here this particular will go up to order of n times, and anyhow this particular is going ahead as per the size of the queue at that particular moment of time. That is the thing. If this particular becomes order of n, then surely this will be order of 1 only, because see this is as per what ever number of nodes are there at a particular level, and this is as per um, that how many levels which are there. So that is the thing. And either the level would be, let me explain that how it becomes order of n. Either you can see the level is so much high, this is because of the level of tree, and this is the size which is there, this is because the number of nodes at a level. Fine. Now the thing is that either of these would be true. Either the level of levels, that would be order of n. So because of that, at each level we are having just order of 1 nodes. That would be the thing. So here it will become order of 1 and here it will become order of n. So that's why overall time complexity would be order of n. And space complexity would be also order of n because we are using this queue. And other way around which is there, why this time complexity remains order of n always, because see, either skew tree would be there, or if a particular tree is even like this, means something like this, so you can clearly see here also the levels which are there, right? The level here, level is 3 and the maximum number of nodes which are there, that is 4. So basically in all this context, if you see, so here if you take it as n, so it becomes like n minus 1, right? So even if that is also the case, but still, because they have mentioned that is a binary tree, that they have not mentioned anywhere that it could be a full binary tree or something like that, means it could be the scenario or it may not be the scenario. That is the thing. So because of all that stuff, it can be like, means something like this also. So there could be possibility like anything could be there like this. Means the difference between the levels and the number of nodes at a particular level, that could be something like this, that it will be always order of n only. Means overall time complexity which is there. So that's why the overall time complexity which is there, that is order of n, and the space complexity, that will be order of n only, because anyhow all the nodes we will be required to keep inside our queue. That would be the thing. Either it is in the form of you say like, if it is levels, then anyhow it would be order of 1 at that point of time, but still queue would be used order of n times there. But if it is like all the nodes are there like up to almost order of n, means there is like a particular, what you can say, means a particular level where a lot of nodes are there by any chance. So in the worst case scenario, that could be the case. So here, this was all for this particular question. If you have any doubt, you could comment that down. And if you feel like, if you have like this could be solved something like this or anything like that, that also you can comment that down. So this was all for this particular video. So yeah, thank you.